So the nutrients is sometimes hard to recognize them because sometimes they look like there is for example here you have a nitrogen deficiency. It could be also a sulfur deficiency. It looks like really the same. So there are many different forms: necrosis, chlorosis, and you have to know how to recognize them. There it's for tomato, iron deficiency, magnesium, nitrogen. So I won't talk about that, but you will have something to see later when you will get the PowerPoint. It's some key of determination of deficiencies. You have two documents, so it can be useful. So in aquaponics, what are the basic success keys? An adequate sizing between fish and plant production, a maximum biofiltration. Sometimes you should oversize your system to be sure to have no problem in the future. So maximum biofiltration, it means enough retention time of the water in the biofilter, enough surface volume ratio for the treatment of ammonia, which is determined by the type of media you put in your biofilter, and also the temperature and the pH. You also require a robust mechanical filtration and a good sludge management system, and enough aeration, oxygenation, and degassing, and not only for the fish part. And then at a daily, and also adequate water flow and a renewal rate in fish tanks to allow the good aeration. So you will have more, it's really an introduction part, so you will have more explanation, I think Wednesday, with Sébastien Stoll, which will talk to you about RAS and different elements of sizing for RAS. And then you have to monitor physico-chemical parameters at a daily basis, O2, pH, temperature, ammonia, nitrate, suspended solids. If you don't do that, it's accurate risk of failure of the activity. It's very important. You have to know how to react and acquire the right reflex. So there I'm talking for commercial scale structures. It can be a bit easier for little structures with low density of fish in the tanks and different kind of materials. Then the factor of risk. Pathologies in fish can be a real problem. Bacteria, viruses, fungi, parasites. Usually you add a UV treatment in your system to avoid it, but it still can happen. Pathologies also on plants. Deficiency, insects, attacks, or fungi. Hydraulic problem, if the pump stops or if it is sized incorrectly, you can have a problem very fast. Filtration problem, because a poor filtration will impact the health of the fish and the correct efficiency of the biofilter. Then you can have physico-chemical problems like lack of oxygen, extreme temperature for fish, plants, or bacteria, a poor pH management, which will create a poor nitrification in the biofilter. And then electrical problem can also be a big one. You always need to anticipate other solution for creating energy, and yes, if the pump stops, the fish can die in 10 minutes, so it's really important. So some reasons for me to opt for a decoupled system. So as I said, this is the example we have in ECF farm system, but also in urban farmers. Also, I think in London, Grow Up Urban Farm. So, and also Nerbrin in Spain. Every commercial system we have visited do that, because I think this is the right choice. You can have the independence between fish and plants compartments. So I think I already said that. You can choose to recirculate or not the water from the plant to the fishes. It allows emergency treatments on both parts, even if we absolutely want to avoid it, because we target a clean production and a nearly organic production, even if we can't have it. It allows also the strategy of the hybrid between aquaponics and hydroponics, a mix, to complement the water of fish origin with limiting minerals, which are sometimes unsuitable for fish farming. That's why you don't send it back to them. And it also allows partnership between two different professions, because it's two very technical jobs, growing plants or farming fish. So maybe the best is to have two activities working together. Just about RAS. So this is what illustrates the recirculation intensity of fish farming systems. There you have the ratio of makeup water per kilo of feed you distribute to the fish. So here, 100, it's the flow-through system. Then, if you add mechanical filtration, oxygen addition, degassing, you can have a partial water recycling system. It will be 40 cubic meter per kilo. Then, what we call the open recirculating system, it will be 5 cubic meter per kilo, and you have to add biological filtration. Then you have the complex recirculating system, 1 cubic meter per kilo of feed distributed. You need to disinfect your water. It's a good idea, and sometimes thermic regulation. And it's better not to put this kind of system in the outside environment, but to have it in a closed building to avoid contamination. And then you have the nearly closed system, 0.5 cubic meter or less per kilo of feed. So this is basically only replacing the water of evaporation and evapotranspiration. Only this kind of loss. Then you have to add a denitrification part, because the nitrates can accumulate a lot. But this is only for RAS. In aquaponics, the idea is to avoid the denitrification, because we don't want N2O in the atmosphere. You know, this gas, which is sorry, N2O.
Yeah, it's a greenhouse gas.
Yeah, greenhouse.
It can evaporate just as nitrogen, right? Denitrification just N2.
Sorry. N2 and N2O.
So.
Yeah, above. So you want to avoid that, and aquaponics is a good denitrification process for that. Then Sébastien Stoll will talk to you about that, I think. The characteristic that define a recirculating system is the flow rate, the amount of fresh water per kilo of feed. This is on the scheme. The daily rate of renewal in the system. So it's the percentage of the quantity of new water on the global volume of the water in the system. So it's a ratio. The dwell time of the water in the biological filter, which will be around at least 5 minutes. The specific surface of the media in the biofilter in square meter per cubic meter. And then the volumetric total ammonia nitrogen conversion rate of the biofilter media. So it's proper to the kind of media, and also to the temperature. It can it's not always the same value. It varies a lot in each system. For commercial RAS, you need to have electrical safety, to double the critical material, like the recirculation pump, to be able to launch another one if the first one stops. You need telephone transmission alarms, and a good management of critical inputs like O2, pH corrector of feed. So now some challenge about aquaponics. The technical challenge first, it's a multidisciplinary approach. So this is kind of complex. It's necessary to stabilize your system in order to optimize the production, the productivity. So it's stabilizing the pH, optimizing the availability and assimilation of nutrients, managing plants and fish pathologies, regulate the nitrate level, both in the water but also in the final products, because there are some sanitary aspects about nitrate concentration inside the plants, so it has to be checked also. There are some socio-ecological challenges and opportunities. Is exploring, for example, the mineral recycling lines for phosphorus and potassium, which most of the time stays in the sludge that you take off of your system. It contributes to strong water saving, so this is an opportunity. It ensures year-round access to... Oh, sorry, I think... Okay, don't care about this sentence. It has nothing to do here. Decrease the proportion of fish meal and oil used in the feeds. So this is a real socio-ecological challenge for aquaculture. Now we have some hopes with insect meal, for example, which will be allowed for aquaculture in next July. So maybe we will manage to avoid fish meal more and more in the fish feed. And then it would be a good idea to promote short food supply chain, and aquaponics tends to go in this direction with urban and peri-urban agriculture. And then economical challenge, because for the moment it's hard to say if it's really viable as a commercial activity. A lot of people tried it abroad, and there were a lot of failures actually, but some really succeed. So we don't have all the key to say is it or not viable. And then you have to educate and train people on aquaponics, and that's why in APIVA we try to develop formation, like how do you say, formation en aquaponie? Training in aquaponics. So it can be in cost, but it can also be in the context of real courses for 1 year, which where you can have a diploma in aquaponics. Okay, so some questions.
Another one. You mentioned also the possibility to, or the necessity to oversize, for instance, the biofilter. And I'm just wondering, like, can there be like side effects or negative effects if it's too big? Maybe heterotrophs start to grow. Have you faced like issues on?
Not really, because if you have a good filtration in your system, you should not have too much heterotrophic bacteria in your biofilter. And then if you have enough aeration in your biofilter, there will be no room for heterotrophic bacteria. You always have some, but oversizing is never a problem for nitrification.
You showed before the nutrient dynamics,
yeah,
an example for nitrogen. It was
at
in the experiment in the previous presentation.
Yeah, at the beginning.
Yeah. I was just wondering, I guess you have the different graphs in parallel for the different nutrients. Yes. And I was wondering if there are very big differences in the nutrient uptake from different nutrients, and if some of the nutrients accumulate really in the system, and also if you try with different plants. For example, if you can see some difference and complementarity in different plants regarding nutrient uptake. That's what we want to do, to try with other plants, because for the moment we only did it with lettuce. So we should try again with basil, for example. It's a model plant, and strawberries maybe, to see if it's interesting. If you have this data, you can just even theoretically see what complementary plants you can put together to...
Yeah, exactly. But Between the different nutrients, there were no accumulation. Nitrates was decreasing, phosphorus also, potassium also. Actually, 100% of the potassium disappeared. So we were at maybe at the end of the production capacity of this system because there were no more potassium. But you have too much nitrates, that's the problem. But all the nutrients we studied were decreasing and there is no accumulation.
I have another one?
Yeah. Sorry, it was in the experiment with only a volume of water which was used again. But in normal circulation of RAS and aquaponics working together, you actually have some accumulation of nutrients. That means that we don't have found the correct sizing yet. If it accumulates, it's that you have too much, not enough plants. It should be stabilized for in the.
Or the feed is not balanced well for the plants. The fish feeds.
Yeah, also. So yeah, developing a special feed for aquaponics is, I think, the next step for aquaponics.
And in the system you talk about, you said you put a lot of new water in the system, quite.
It depends on the pilots.
You use it also to control pH.
Yeah.
But so if you put inside new water, so you also have more wastewater. So because the philosophy of the aquaponics system is just to recirculate everything, so you have to discard a part of the water with your nutrients, no? Or you manage to use this water in another way.
Yeah, maybe it can be a solution to use the water, for example, for irrigation of fields. But depending on the fish species, you won't have the same potential of closing the system. For tilapia, you can easily totally close the system.
One with tilapia is totally closed.
Yeah, you can be totally closed, and because you have the evaporation and evapotranspiration, so you add some amount of new water, it's not a problem. But for trouts, it should not work so well because they are very demanding concerning the quality, and yeah, you can have mortality very fast with this kind of species. But maybe it's better to go in this direction to make herbivorous species like carps, tilapia. When you see in the world, they are the most consumed fish and they are the most ecological. For carnivorous species, it's a bit more complicated. But in Rato, we managed to have a really close system for trouts, but they have this off flavor. That's the problem. The more the fat inside the fish is elevated, the more it accumulates the flavor. So tilapia is quite okay. You can rinse it fast, but trout, it is more fatty.
So, is there importance changing in the water physical-chemical parameters between the day and night time?
Not really, no. Actually, what is interesting to see is you can look in every part of the system in our pilots. It will be the same amount everywhere of nitrates, for example, before or after the biofilter, or before or after the plants. It seems that it doesn't really decrease because you always produce over waste from the fish. So you can't really see it. That's why we made this experiment on watching how much the plants are taking from the water, because we were not able to see it inside the working system when it was because it's the water flow is so fast that it's homogeneous everywhere.
I don't know. In aquaponics system in the night time,
yeah.
Is there using artificial lighting?
We don't, but some people do. For example, in farm deer in USA, I think it's 24 hours per day of light with LED. So you have yeah, a huge productivity with that.
Actually, it depends. If it is commercial system, you need to grow more plants in a certain cycle of time or certain duration of time. So you need to give artificial light, and it depends on the region you are growing. If it is in greenhouse, you need to, and it depends on daytime lighting. So if duration of the daytime lighting is less, then you need to give more lighting. Otherwise, in tropical area, you don't need. If it is outside, but if it is in greenhouse, you need to give more lighting.
Other questions? No? Okay. Now, after all these technical problematics, first the use of exotic species. In Europe, there is a regulation saying that you are allowed to raise any type of fish if it is a closed system, and you don't even need introduction permits for exotic fishes. But in France, it works a bit differently, because you have a list of represented species, and we don't have the right to rare other species. You have to ask to the administration, and most of the time they say no. So there is in France a need for lobbying and maybe jurisprudence after a successful project, because some people try, they ask, and usually they don't success. I don't know in other countries. Maybe it's a good question to ask. Is it a problem in your countries to rare locally absent species? No.
Depends on the system, that's it.
If it's closed, they don't see any problem. Yeah. So concerning the country, depending on the country, unfortunately, it's really not the same potential of development. And then about the status of the irrigation water, we can ask ourselves the question: do we have the right to sell products that are grown in livestock effluents? There is existing regulation for spreading sludge in agriculturing and fish farming sludge on plots with spreading plants. But aquaponics is not really classified in administration text. In France, I don't know if you're in your country again, what is not allowed is generally forbidden. But maybe it's not the same in your countries. But the fact is that in France it should be considered like treated wastewater in contact with manure and digestive tract content. It looks like a lot like this definition, which is je sais pas comment dire ça, encadré par la loi. Non, ok. Personne. Un encadrement juridique.
Legislation.
The legal framework.
Legal framework. Legal framework. Yeah.
Framework. Right. Legal framework.
So yeah, what we can say is there is a big black hole on the legal status of fish water for irrigation of plants, because this definition doesn't correspond to fish, because it is said that digestive tract content only refers to mammals and birds, but not fish. It is said not the fish. Then there is a sanitary aspect. You have some rules on the plants you want to sell, so you have to check if you don't have Escherichia, Salmonella. Based on our experience, there are no problems with aquaculture effluents for these parameters. Also standard for nitrates level. Concerning depending on the season, it will be different, and it only concerns lettuce and spinach. You shouldn't go to an upper value Then the value that are indicated here in milligram per kilo, milligram of NO3 per kilo of fresh tissue of plants. And then about the organic labelization. So we all know that it's forbidden both for the plants and for the fish side because it's soilless for the plants, so it doesn't. It's in contradiction with the principle of organic agriculture defined in the European regulation. And unfortunately, it's the same for the fish side. Even if you use biological feed in your system with no inputs, no chemical inputs, you can't have biological fish production in Europe. But maybe we'll see a development in the future because in Canada and USA it's not much of a problem. So yeah, we need a suitable and new legal framework for aquaponics. For example, for the status of the operator, the status of the structure in aquaponic. Maybe we should create an alternative label. It could be aquaponics only, or ecological. It could be a collective trademark, or some people like Nurbrin just put no pesticides on the package, and it can work. But all this law evolution should rely on a lobbying force, maybe a collective, a group of project holders. So in France, it's starting to develop. There are different associations of project holders, and maybe we'll see some evolution to have a good framework for aquaponics in Europe. For the moment, only England really have a real legal framework for aquaponics. There are official papers to determine what kind of aquaponics structure you get, and you can really exist from the administrative point of view. Questions?
What about your country?
I think there's like also a lot of black holes. For instance, in the Netherlands, it is not allowed to feed the fish with living animals because of animal rights stuff that are written. So many people try to produce like with worms for vermi treatment, and then you cannot use the worms to feed the fish because they are alive. So those kind of issues. I think that's local Netherlands, not even European Union.
Wow. And other people have encountered
no insect anymore.
No insects?
Unless they are dead, but then you have to go through the legislation of how do you, because there's no insect production for feed or for food for people. This is also new, so there's no legislation, and you cannot feed fish with.
In France, the food company, the food pellets for fishes, food company, it's legal in July this year to put insect inside.
But
the
it's
pellets.
at a European scale.
Mm.
In July it will be allowed, finally.
Yeah.
Pesticide?
No, insect.
Insects.
Insect. As an ingredient, you know?
To replace fish meal, for example, as a protein source.
In Turkey, we are trying to new aquaculture legislation or some, but there is no words also agriculture in dictionary aquaponic. And new things maybe for many countries.
If I can put it like almost poetically, is that we sort of have to remember that science doesn't follow the laws of men, but we are there to understand the laws of nature and push them into the laws of men. So I think it's kind of our work to communicate with authorities and to push them into to do their job and start doing the same.
actually soon a small committee from the Cost Action EU Aquaponics Hub will go to Brussels to meet the European administrations, taking care of aquaculture and things in June. To discuss about all this, to make a bit of lobbying about the status of the producer, about the legislation, the certification, all the point that you mentioned.
Okay.
Yeah.
Because there are some publications about that, but for the moment we don't know where we are in Europe.
Nobody knows, so they want to clarify the situation and to go forward in this, because some people, they want to start a business, but they are stuck. And
some people already began, but they don't know if they can sell their products, but they do. In France, there is 1 or 2 producers, aquaponic culturists, and well, they don't have any problem, but from a day to the day after, maybe they will have. So it's a risk. But that's nice to know that cost will treat the question.
We learned it last week. On l'a appris la semaine dernière.
D'accord.
So, few minutes to
yes, if you want.
Okay,
Okay, the last part is maybe not so important. It's on different review, maybe 1 or 2. So little review on what already exists in Europe or in the world more largely. This is in Quebec. It's a Marc Laberge company, Aquaponics Inc. It's only 840 square meters, so we can say it's a medium-scale aquaponics system. But you can produce 7.5 tons of fruit per year and 48 tons of lettuce for, I would say, only $450,000 of initial investment.
Canadian dollars? Or?
Canadian dollars, yeah, I think.
Marc Laberge.
This is interesting. It's in United Arab Emirates. So this might be one of the biggest aquaponics system. 4,000 square meters of vegetable cultivation. They say that they can produce 1,200 lettuce per day and 200 kilos of tomato per day, without any fertilizer or phytosanitary products and no antibiotics. It's written on the website. But I don't really know. We didn't check. But it's in an urban environment and in a very dry and warm area. So that's interesting to see that you can do aquaponics quite everywhere in the world, even when it's a desertic region. Then we have aquaponics in industrial wasteland. We have 2 good examples of that. It's a farm deer and urban organics in the USA.
I think farm deer stopped aquaponics.
Yeah, I wanted to say that. They began with aquaponics, but now they think that it might be not so much economically viable to their point of view. So they just do hydroponics because they know that they can sell their products also in hydroponics. So I think they just conclude it's easier than aquaponics. But they started with aquaponics, and urban organics is making aquaponics. They make tilapia and produce 326 tons of aromatic herbs and 68 tons of fish per year. And they sell everything to the local organic wholesalers. So they don't target supermarket and this kind of market. They use a raft technique on 3 levels with LEDs all day long. And 1 floor only can produce 5,000 tilapias and of this weight every 9 months and 20,000 salads every 50 days. So it's quite interesting to have all these informations. This also is interesting. It's Global Aquaponics Inc. also in USA. On their website, they put all the some sizing information about annual food production. They produce fish and shrimps and many different vegetables. And so they put the sizing for 10 tanks, 20 tanks, 40 tanks, and in parallel they put the surface that you should have with this kind of system and the full-time equivalents that are needed. So you can see the economy of scale that is possible. Then you have aquaponics at medium, large scale ECF farm systems that I told you about. There is no artificial light. It's a decoupled system, and they use they add nutrients to grow tomatoes and all their vegetables. So it's an hybrid. They can reduce the quantity of nitrates and phosphorus thanks to aquaponics, but they decided to use other nutrients to have a maximum productivity all year long and to avoid the difficult equilibrium that you have to reach in aquaponics. So yeah, it's a bit long. Different approaches basically, but you have the very small scale, the medium scale, large scale, and very large scale, as we have seen. The small scale is more for hobby, usually in coupled configuration. It's for self-production, so no viability expected. Low tech, they usually use growing media for filtration, and for both mechanical and biological filtration. They don't put oxygen as an input, and usually they can't go. They have a rearing density of fish which is quite low, no more than 10 kilo per cubic meter, and this is optimistic. And the opening rate of the system, it's only the compensation of evaporation usually. But at a medium scale, it will not be the same. Between, we'll say, 50 and 300 square meter, it should be difficult to reach a viable business. So it's mainly for education, demonstration, or a first try of commercial production for a future scaling up of the installation. Generally, it's coupled, but it can be also decoupled. It's all about the technical choices. Generally, to be economically viable, they have to make a lot of trainings and tours of the installation. So it's a lot about communication. It's low tech or semi-high tech. For mechanical filtration, they rely on growing medias, but also sometimes on decantation with a decantation tank or a small drum filter. Usually they put at least aeration for the fish, and they can reach quite better density than in a very small scale. And they just need to compensate evaporation. Then you have large scale and very large scale, more for commercial production. Generally, from what we've seen, it works in a decoupled system because of the flexibility it allows. It's an intensive production to maximize the viability. And they target the economic viability. I don't know what. They target viability with the production. So they only rely on what they produce to be viable, and sometimes also some tours of the structures when they have time. And it's high tech with a drum filter, static or moving bed biofilter. So it also consumes a lot more of energy, and this is one of the main limits in aquaponics. It's the cost of production with the energy, because RAS systems are very demanding on electricity. But they compensate that with targeting high density of fish in the fish tank. and they can operate with very closed system, very low opening rate of the system. So I think I will just here. It's okay, interesting to see. It's an Evergreen Republic in Hong Kong. They don't have okay, they have actually organic. They can sell aquaponics with organic label, but they have a very good communication packaging. All they ever produced are valorized with very nice packaging, and with communication you can really sell your products in aquaponics a bit more expensive than the conventional ones. So that's maybe how aquaponics could work. Okay, I think I will stop there. Thanks you for your attention. If you have other questions.